Okay, so we're going to multiply fractions. Okay, that's a very good question. It is 10 to 11. We have 25 minutes to do this. It's not going to take us 25 minutes to do this. However, tell your band folks that are in band with you that they're probably going to miss 10-5 or 10-4, sorry. So that video will be up so they can check it out at home if they need to. All right. So, in our last lesson, we multiplied whole numbers and we took a whole number and we turned it into a fraction. Okay. It's one of the few times in math that we're going to go from doing something that includes an extra step to something with less steps. So, we're going to, Franco ate some pizza. 2/3 of a pizza is left. Deandra ate 3/4 of the leftover pizza. How much of the whole people did Deandra eat? So we know that there's 3/4 of a pizza left, and she ate 2/3 of 3/4. Okay? Now, 3/4 entered our problem first, so they wrote it first. Remember, property of multiplication says it doesn't matter which direction you multiply, right? So whether you multiply 4 times 3 or 3 times 4, it's still 12. All right? We write our problem down. We extend our line. Note the numerator's on top, 3 times 2. Both the denominators on bottom, 4 times 3. 3 times 2 is 6. It's on top. 4 times 3 is 12. That's our denominator. It's on bottom. Okay? Now we look at 6/12. Can we reduce it?
Yes.
Yes, because when we're working with fractions, we always want our answer to be in what? Simplest form. So we need to simplify. Okay? So 6/12 can be divided by 6. 6 divided by 6 is?
1.
12 divided by 6 is? So our answer is?
1/2.
1/2. She ate 1/2 of a whole pizza. Now, they want to show us something called cross canceling. Now, if you get good at this, it makes multiplying fractions very, very easy because it gives you smaller numbers to work with and it eliminates simplifying. Okay? So, they show us it right here. The only problem with the way that they show us is that it's already done. So, let's walk through it real quick. We have 3 times 2 all over 4 times 3. Now we're going to look for things that we can do to the top and the bottom. So the first thing we can do is we can divide by 3 and get rid of our 3's. Okay? So we're going to go 3 divided by 3 and 3 divided by 3. So what happens to our 3's?
They become 1s.
They become 1's. So now I have 1 times 2 over 4 times 1. Now if I look, I still have 2 even numbers.
You can simplify.
What can I divide 2 and 4 by?
2.
2. So 2 divided by 2 is
1.
So now I have 1 times 1 on top. And 4 divided by 2 is
2.
So now I have 2 times 1 on the bottom. So 1 times 1 is 1, and 2 times 1 is 2. Okay? So you can see that cross-canceling, it eliminates, it lets you divide smaller numbers. It lets you work with smaller numbers. Yes, sir.
Do you have to do it like that?
No, you don't.
Okay. I'm not.
If you think it's easier, then you do it that way. All right. Our next example. Okay, so our second example is we have to find the area of a rectangle with a length of 3/4 of an inch. 3/4 of an inch, and with a width of 5/9 of an inch. Okay. So what we've done is we created a rectangle, just like we did yesterday with our. Devin, can you stop talking to her? Joe Walter, where's your book? So how did you tell me that you were done with your homework if you left your book at your house?
She did it. She went to work.
I need you to stop talking.
It's probably we're sitting.
Now, this side we have divided into 9 pieces, just like we did with our counters yesterday with our hands-on lesson, right? And 5 of those 9 are shaded in. So that's 5 9s. On the bottom, we have 4 pieces, and 3 of those pieces are shaded in, which gives us our 3/4. We shade in the rest of them. Okay? So how many pieces are shaded?
15.
There are 15 pieces shaded. How many total squares are there?
36.
There are 36. Okay? So, this is our modeling. This is how we did it yesterday. Now, how we're going to do it today. Well, let's reduce it first. We have 1536. Okay? So 15 divided by 3 is 5. 36 divided by 3 is 12. So we have 5 12s. Okay? So yesterday, we modeled it just like that. Okay? Today, we're going to multiply it. So we set up our multiplication problem as so. Then we put our numerators together and our denominators together so we can multiply them. 3 times 5 is 15. 4 times 9, 36. Okay? Then we simplify. They already told us we're going to simplify it by dividing by 3. So 15 divided by 3 is 5. 36 divided by 3 is 12. All right. So far, so good?
Yep. Yeah. Wait. Oh.
All right. So the area of the rectangle is what square inch?
5/12.
5/12.
Oh.
5/12 square inch. All right. So here's our guided practice for independent work. So we're going to find 1/7 times 1/2. We're going to write it in simplest form. This is key.
Simplest one.
When working with fractions, we want our answer in.
Simplest form.
Thank you. So here we have our multiplication problem. We put our numerators together. We put our denominators together. 1 times 1 is?
1.
7 times 2 is?
14.
Remember what I said if there's a 1 as a numerator? If there's a 1 as a numerator, can it be reduced? No, it doesn't matter what the denominator is. If there's a 1 as a numerator, it cannot be reduced. So our answer is 1/14. Okay? Now, our first 3 problems for our independent work are modeling. You guys did this yesterday. They want you to use the model to check your answers. Okay? I am not going to do one of those.
Oh. Do we have to do the modeling?
Yes. Fine, I will do one of those. I will do. All right.
not the first one, the second one.
Second one. Okay. The second one says 3/10 times 5 6, correct? Okay, if we look at the bottom across here, this is where the 10 squares are, correct? Okay, so how many of those need to be shaded? How many of those need to be shaded?
Three.
That's where 10 squares are. 3 need to be circled, shaded. Because I need to show 3/10. This is where the 6 squares are. How many of those need to be shaded?
5.
5. Now, once we've shaded both of those, we can see that the 3 ends here and the 5 ends there, which means everything inside of there has to be shaded. Boom. So how many do I have shaded completely? 15. And how many are there?
16.
Can I simplify?
Yes.
How?
Oh, divide it by 5 and then divide it. Wait, 16 divided by 15. You can divide it by 5 2 times or 15.
You can't divide it by 5 2 times. You can divide it by 5 and then 3.
Oh yeah, 3.
Or you could just skip that and divide it by 15. 15 divided by 15 is 1. 60 divided by 15 is 4.
4. Oh, I got that.
Okay? Now, you want me to go back?
Shall we start?
I'll do one more problem for you guys, and then you guys. Lucas, which problem do you want me to do?
Number 15.
15. All right. Lucas says do 15. So you can see all this here. You're going to multiply the numerators, denominators, and put it in simplest form. Okay. Same thing. They put letters in at the end just to try to trick you, but the letters represent the answers, so the answer is x equals the answer of the multiplication problem. All right. 14. They want the area of the rectangle. How do you find area?
Multiply
Length times width. Length times width. All right. We're going to identify structure. Refer to example 1. Complete the steps to show how 3 times 3/4 times 2/3 can also be found using properties of equivalent fractions. So you're going to multiply the numerators, multiply the denominators. Can also be found using properties of equivalent fractions. Well, what does that mean? That means that they're fractions that what? Nobody knows? They're fractions that equal each other.
equivalent.
Properties of equivalent fractions. Using properties in equivalent fractions. So what they are telling you is that you're going to rewrite it and you're going to put all these numbers, numerators and denominators, okay? Okay. Remember we talked about the commutative property of multiplication, which means that 3 times 2 equals 2 times 3. Either way, it's 6, right?
Yeah.
So what they're saying is you can flip-flop your numerators, which they did here. So that's your commutative property, okay?
next one is.
I think I spelled that right.
We have to do the hot copy.
Okay.
No.
Now, the commutative property shows us that now we have 3 over 3. 3 over 3 equals
9. Wait. 1 whole.
3/3 equals 1 whole, which they did for us. Okay. So 3/3 equals 1. So, and then it down here it just says equals 2/4. And who said I know the next one?
Jeremiah.
What is it, Jeremiah?
Equivalent.
No.
I thought it was.
No. What property says that something times 1 equals itself?
Oh. Let me see that.
Distributed.
Oh,
No.
up there.
It's not actually
You
the
got the
Five
N.
factors.
You put commutative. It's fine.
commutative property for the first one says that you can change the order in which you multiply. And it does not change your answer.
Distributive property.
Yes, it's not up on the wall yet. It's back here. The
The
identity property of multiplication says that if you multiply a number by 1, the answer is what?
That number.
The answer is that number. So in other words, the reason why they call it the identity property. Let's say I want to know Lucas's identity. If I take Lucas and multiply Lucas by 1, I get what?
1.
I get Lucas.
Oh, very.
Because anything multiplied by 1 is what you started with. So, I changed 3/3 to 1. And I have 1 times 2/4, which means all I need is 2/4. So this is identity. Okay? So we're good to go? Everybody's happy? Everybody's smiling.
Everybody's fine. I can't read it.
Fantastic. IDENTITY. All right. Band, you're leaving in 5 minutes, so make sure you get some work done before you go. Everybody else, you have time.
Okay. Let's see.
If we're talking, we're going to have less time because we're going to have more work.
You have to do these ones, the hot problems. These ones. You have to do these ones.
Yeah, you should do that.
Okay, now can I ask you my question, Mr. Brennan?
All the time, huh? What's your book?
Nice. Now can I ask you my question?
Let me finish this real quick. Somebody's leaving.